All right, so it is recording ITS 365. Audio is on. Okay, so let's proceed then to talk about the topic for this week. So we should be able to get through this topic in 1 week. So today, basically, and on Wednesday. All right, so you should now be seeing the whiteboard. Okay, so as I said, the topic for this week. So all of the semester so far, about 6 weeks, we have spent. So if you remember, let's just start at, machine learning can be divided into 3 areas, right? So we've talked about that. So we've said how, it can focus on supervised learning, and then there's unsupervised learning, and then there is reinforcement learning. Okay, so these are the 3 basic areas that we can take a look at. So far in the semester, we've spent about 6 weeks covering this, right? And we have and we'll come back to it, of course, when we start looking at the more advanced topics like neural networks. But for now, that's what we've completed. And the assumption with supervised learning was, as you remember, that you always had an X matrix and a Y vector, right? And given this information, you were able to do some analysis. As we will see, for now, for this new phase, we can focus on unsupervised learning, right? So we can focus on unsupervised learning. Unsupervised learning includes several things, like something called k-means, which is basically an algorithm for something called clustering. That's something that we will cover later in the semester. It's more of an easier topic to cover, so I'm going to leave it for later. But there's k-means. There's other things like, like the one I'm going to cover today, singular value decomposition, right? Which, it's, as I said, it can be used for dimensionality reduction, but also for recommender systems. And that's, one of the things that I want us to focus on. It is a machine learning technique, just it's different. This is going to be different from what we've done so far, right? But it's you'll see why I think it's really important, and so on, right? So on. So I will obviously I'm not able to cover all the algorithms, but I'll cover some of these. So, and then reinforcement learning, of course, which we will cover later when specifically we look at Q learning, but that will be later. All right, so the focus then right now will be, unsupervised learning. And in particular, we're going to focus on singular value decomposition and its applications. Now, the difference, the contrast that I want to make between supervised learning and unsupervised learning is this. It's about the data, right? So let's go to another slide, and let's just kind of say, well, here I have supervised learning, and here I have unsupervised learning. And the thing was, as probably you're very familiar with now in the semester, because we've spent a lot of time on this, you always have an X and a Y, an X matrix and a Y vector. All right, you have that. In unsupervised, you only have the X matrix. Okay, there are no labels. So here you have the classes or labels, right, and the data, the samples and features. As you know, let's say here, actually, let's go over here. So samples, features, right? and you have the labels or classes. Here, you still have, you know, data, samples, and features, but you no longer have labels, right? So, you know, no labels or classes. Okay, so that's the big difference with this, right? So that's the big difference here, is that we don't have that anymore. Okay, and so we're gonna look at ways of just inferring anything from just the data, from just X, okay? Okay, so as I said, in unsupervised, there are several techniques, and people, you know, might expect like k-means to be the first algorithm that we would look at, but I'm actually not going to start with k-means, and instead I want to start with something really powerful, which is called singular value decomposition. And just because I really want to talk about recommender systems, okay? So now that we've kind of placed this, you know, we should be aware of where we are, right? So this is what we're going to be covering on this side now. So it's a new type of approach. All right, so now that we've talked about that, we're going to talk, first of all, you know, not about, say, the application, but just the technique, okay? So the technique that I'm going to focus on is called singular value decomposition. So I'll start, you know, instead of starting with the theory and then leading to the code, as I often do, this time around, I'm going to start with the code and work my way back to the theory. We will cover the theory. So probably it's like I'm going to invert a little bit the lectures and the lab. So today, you know, we'll be doing some coding, but I just want to make sure that I give you the code because you will have so the previous homework assignments we've done have been pretty just algorithmically focused, not so much application focused, right? But this homework assignment will be very much application focused. And what I mean by that is that, you know, you could actually do this. You know, if you had a business, you could actually do this, right? That's sort of what I want to show you in this pipeline. I won't require you to do all these things, but I'll just show you how you have already the capability to do a lot of these ideas. All right, so singular value decomposition, short for, you know, SVD. All right, it's a technique basically from linear algebra. So it's a math technique, you know, that has existed, you know, before machine learning, right? So math technique from linear algebra. And I'll go over, you know, the details of it, but really, as you might imagine with Numpy, etc., it's usually just, you know, like one function call. You make a function call, and you will get your singular value decomposition parameters that you need. Okay, so in the case of singular value decomposition, as I said, all we need is the X data. So we don't need labels for this technique, right? So we will not need to figure out labels, although this would work. Singular value decomposition could actually be used for in supervised learning as well. So it could be like a singular value decomposition could be like a pre-processing step for classification. But in itself, singular value decomposition can also be used on its own for a standalone type of machine learning tool, right? So that we can use for our purposes. All right, so so then, as I said, we're going to be using this. We can think of singular value decomposition then. We've already defined that it's a technique, and the technique will help us to in two ways, right? It can help us with feature compression, or feature compression, let's see, which is also, you know, dimensionality reduction. Okay, so it can help us with dimensionality reduction, feature compression, and it can help us with recommender systems. Okay, so it's not feature ranking. So let me just make a note about that. So when you do dimensionality reduction, let's think about that. So dimensionality reduction, right? What is that? Basically, you have a matrix that looks like this: F1, F2, F3, dot, 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 Fn, sample 1, sample 2, sample n, dot, dot, dot. So you have that idea. So now this might be, you know, 10,000 features, right? So this could be 10,000 features. That's a lot of features. So your memory may not be able to do this, or what have you. So there are two ways to arrive at a smaller matrix. Okay, still the same number of samples, S1, S2, all the way to Sn. Actually, let me make Sn and m. So Sn, S1, S2, dot, 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 Sn. Your goal here is to arrive at a new, so there are two ways, right? There are two ways. One is you could do feature ranking, which is what you sort of learned how to apply with Weka last week. So feature ranking basically means that you have the features F1, F2, but then, you know, F4, dot, 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 K, where K is less than M. So what that means is that you are going to literally keep the same features, but you're going to drop a few. If you notice here, for instance, I dropped F3. All right. So in feature ranking, you're going to use some kind of an algorithm, like the one we used was information gain. If we have time, we will cover these, but I just don't know that we will have enough time. Or the chi-square. All right, so those are algorithms for feature ranking. They allow you to literally drop the features that have the least amount of contribution, but it's still the same features. Another technique is called, and so that was feature ranking. The other approach to reducing the feature space is to use feature compression, let's call it. Compression, right? And that's going to be something like a couple of techniques, PCA or singular value decomposition. So I like singular value decomposition. I just think theoretically it's very easy to understand. And also, like I said, you know, there's a very, you know, we can apply it to recommender systems. So it's actually a very interesting topic to cover. So we will cover this one, of course. That's what we're covering this week. With this one, we do feature compression. We also reduce the number of features, but this time around, we don't use the original features. Instead, we use what are called linear transformations of the feature. So what that means is that I'm going to have, instead of the F's now, I'm going to have, let's say, P. So P1, P2, P3, dot, dot, dot. Can you guys hear me? Guys?
It just started to go in and out. I wasn't sure if there was an issue.
It did that on my side too. How about now? How is it?
It sounds fine now. Like it just started though, so I mean, no real way of telling.
Okay, yeah. So let me know if there's any problem immediately. Let me know. I might have to reset that router.
Okay.
But just let me know. Okay, we'll continue. All right. Just if it sounds okay, because you know I can't.
No, it sounds fine now.
Okay. All right. So as I was saying, then with feature compression, we create a new set of features, P1, P2, P3, all the way to P and let's say PL, because L could be any number. And again, where L is less than M. The goal is, as I said, obviously the fewer amount of features you have, the less RAM you're going to consume on your computer, so the more processing you can do. And these techniques, later on, we will see that basically, intuitively, we can think of that P1 as nothing more than a linear combination of the original features. So F1 plus, weights. We have some weights associated that we have to learn. So let's see, W2 times F2 dot W M, I guess, times FM. You see that? So it's basically what is called a linear transformation. So the new features are made up of the original features plus some weights, and there's some kind of a learning objective. There's an algorithm that we have to follow, obviously, to know how we're going to learn these mappings. But at the end of the day, then, you can produce, intuitively, you can think of this, we can produce all the way to PM. So we can create the same number of features. So we have F1 to FM. We can create the same number P1 to PM. However, there's an additional component that says, yeah, but by the way, these new features that you're created are kind of ranked. So what we're saying is the first one is the most important, then the second one is the second most important, and so on. So at some point you can just cut off and just, kind of exclude the rest, and that's how you end up with fewer features, right? Because, that's the algorithm itself. So that's feature compression, and that's, just intuitively, I wanted to give you a basic idea of what singular value decomposition can do for that. However, we're not going to cover that today, but I wanted to just say that as a side note. Okay. So really, then, if we've talked about this, right? So we've talked about feature compression, and you hopefully have a basic idea, although I haven't really covered the algorithm for that yet. The other thing that you can use singular value decomposition for is, of course, recommender systems, okay? And recommender systems is actually the topic of today, what we're going to talk about today. So I'll begin with that, and then we're going to work our way back into singular value decomposition, and then from singular value decomposition, we're going to work our way to feature compression later on, okay? But I'm going to work my way that way, if you will. So I just think it's pretty important, a pretty important topic, especially in today's digital everything, right? So we buy everything online, so it's certainly something that needs to have a lot of attention. All right, so let's now that I've talked about all of this, we're ready, I think. I've led up to, talking about this, right? So talking about recommender systems. So now let's proceed then to that topic to motivate it a little bit better. So let's go to a new slide. All right, so now the topic is, in fact, recommender systems. Okay, and so we're going to think about that. We already know it's a type of unsupervised. We only need X. All right, we don't need labels. It's unsupervised, and we're going to be basing. Now, you can build lots of recommender systems. I mean, you can build one out of your own intuition of things, right? But this one in particular is going to be based, as I said, on singular value decomposition. Okay, that will be the technique. And so I'll give you a little bit of history as to why we do this. So let's start with, one thing that we all love, right? Netflix. I think it's safe to say everybody loves Netflix. Okay, so let's take a look at Netflix. So I don't know if you guys remember how Netflix used to be these DVDs, right? You would go, and I think they still have the DVD boxes somewhere. but you used to get the DVDs via the mail. I used to love actually to go to the DVD store and just look for a DVD on the shelves, but unfortunately those times are now gone. Anyway, so we have Netflix here, and if you remember Netflix when it started, you know, I think 10 years ago or something, you would basically go and they would ask you, you know, what do you like? Do you like this movie? Rate it, right? And you would do ratings of the movies. Do you remember that? So that was part of the mechanism. And then they had all these, so what they had was all these users. Netflix had all these users. They had all these movies because that's all they, or TV shows, whatever, programs. And users had rated the movies. They had that. So you had the scenario where you have, you know, Bob, and Bob has seen The Matrix. And Bob also saw, you know, Out of Africa. And Bob also saw, you know, Bill and Ted's Most Excellent Adventure, right? So, and then you have, you know, Benjamin, Ben, and, you know, whomever, right? Mary. So you had all, you know, a bunch of users, right? You have their user IDs, etc. You guys are very well versed in databases, so you can imagine how that works. And then you had, this was basically a ratings matrix, right? A ratings matrix. And so in the ratings here, you would, you know, Bob would say, well, I really like The Matrix. Oops. So then, you know, Bob would say 5.0. But Ben actually didn't like it. 1.0. Mary liked it, so 4.0. Mary liked Out of Africa, 5.0. Bob also kind of liked Out of Africa. Ben did not like Out of Africa that much, but Ben liked, really, you know, likes comedies probably, and so he liked Bill and Ted's Excellent Adventure. Bob sort of likes it, and Mary does not like Bill and Ted's Excellent Adventure, right? And it continues like that. So if you notice, this ratings table is actually going to be, for our purposes, our X data, okay? So the samples are now the users. And as I said, this can adapt to other things, like this could be, you know, a supermarket, right? So instead of movies, this could be products in a supermarket. This could be YouTube videos. This could be books in Amazon, you know, whatever it is, right? It could be lots of things, but it's, at the end of the day, you know, it's a recommender system, and we want some, I'm going to keep it simple, so I'm going to motivate it by talking about Netflix. So on this end, then we have movies. So we have users and we have movies, okay? And so the idea is, what Netflix wanted obviously was, well, we have all this data, we have all these users, we have all these movies. You know, we want the users to watch our movies more, because the more they watch, the more they become, you know, the more they like the service, the more we can charge. Or imagine that you're selling one movie at a time. If they show me a bunch of movies I don't like, I'm not likely to buy them. And then, you know, but if they show me, you know, they show me a movie I like, I'm more, you know, I might spend the money, and then, you know, that's what Netflix wants, right? They want to increase their revenues. Make sense so far, guys?
Yeah.
All right, so that's the general idea, right? So in a recommender system, so then Netflix said, well, you know what? We have all this data. What do we do? So they created the Netflix challenge, right? So the Netflix challenge was like a machine learning competition. And then they had several people, and they had several, you know, let me, I forgot the name of the person. So it was or the Netflix prize, I think it was called, not challenge. And it was, what's the name of the guy that, I forget, you know, I can't find the name, unfortunately. But it's somebody, some guy, he came up with an algorithm, right? So he came up with a solution that was pretty good, and it was based on singular value decomposition. So it became kind of famous. And that, you know, that's basically what we're going to look. And then obviously you can still use it. I'm sure the people that will implement this in the recommender system, they've adapted it, right? So there's like, let's say the adapted version of singular value decomposition. Okay. So the person introduced the algorithm, and then, you know, it performs really well. It performed really well. And so that's really the basis for what we're going to cover, you know, this week, right? So we're going to talk about recommender systems, how that could be implemented, and how that would work. And so we'll go over the code. Now, the trick is that, you know, you need the data, right? So obviously you will need data with ratings in it. And so that's one of the things that we will have to look. Okay, so now that was a little bit of history, although unfortunately I forgot. I still can't remember the name. Okay, so let's go ahead here then. And now let's kind of motivate this. So imagine that you have a business, right? So that, like, you know, you're an entrepreneur, and you start a business, you want to sell something, you got users, and you got all these products, and you want to make recommendations. So how would it work? Well, obviously you have some kind of a website, you know, imagine like Amazon, you know, something similar. And then you have your database, you know, your SQL, MySQL database, right? So in the MySQL data, you have the information about the users, the movies, and the ratings. Right? So you have that information in your database stored. Every time a user clicks on something, they like, not like, all that is stored in a database. So every night, let's say every night you have a server, you know, you have your Linux server, and it's got a cron job. So you're running a cron job of some kind. And what that cron job does is it runs a script. The script downloads the user, movies, and ratings data. And imagine that could be very large, right? So that could be very large data. So it's going to download it every night, your X data, okay, with information about users and information about movies, okay? And basically then you're going to run your algorithm. So you're going to run, you know, your machine learning, you know, singular value decomposition based recommender system .py, right? You run that script on this data every night. You obtain some results about recommendations, and then those results are once again uploaded to the database, right? So once you complete that job, you know, every night you can run it offline, if you will, right? You just run it on the database at 2 a.m., 3 a.m. And then once you run it, you update the database with new suggestions for the user. So that the next day when the user logs in to buy a product, you know, they're going to check their order or whatever. Well, guess what? You have a little, you know, little thing down here, like a carousel suggesting new movies, new products, whatever. And it's going to be based on, they're going to be recommendations based on what this algorithm thinks that user will like. Okay, so that's really the main idea there. And that's how you could build this recommender system, and you could implement it in your environment, right? So it's pretty straightforward, and you guys honestly have all the pieces that you want. If you want to, you know, all you need honestly is an idea. I mean, you guys can be entrepreneurs, you know, go to GoDaddy or AWS, get some servers, build. You can, you have all the background for databases and dynamic web development, client side, server side. You know Linux very well, and so really, and now and now you have a recommender system, right? So you have your recommender system, and so that'll increase your revenue. Okay, it'll increase your revenue. So anyway, that's the idea. Okay. So now you have kind of the motivation. The homework assignment that I'm going to give you is going to be something similar to this. All right. The example I'm going to do in class is going to be based on movie reviews, right? So movie reviews, obviously I've been talking about that. I'll talk about the data set a little bit, but you guys you will have to pick another data set. So you'll have to find another data set not related to movies. It can be something else, products in a supermarket, etc. And there are other ways also that we could build recommender systems with other algorithms, autoencoders, etc. But in this case, we're going to take just a classic example of the recommender system based on singular value decomposition. So you guys will have to, in your homework, will have to implement this. This will be a more challenging homework assignment a little bit because of the analysis. And that's actually one of the reasons why I'm kind of covering this in reverse, is because I will give the code, then I will kind of give the theory behind everything, and then I will leave you guys to, based on the code that you have and the theory as you understand it, to try to find insights. That's what you will have to show me, right, in the homework. It'll be, I'll ask you to demo it actually, and I'm going to ask you to just recommend some products. That's what I want. So maybe I'll rate a few things, and then you will recommend, based on your ratings, I think you would like so-and-so product. All right, so that's the goal. That's the goal. So let's go ahead then. Now we're ready, I think, to talk about our recommender. So and some of the challenges of this. Okay, so the main idea, I'm not going to get into all the theory of a recommender system, but the main idea with a recommender system is that you have your X matrix, right? And then you have all the users here, like you have user 1, and then user 2, ... all the way to user n, okay? And then over here, you have the movies. So you have movie 1, movie 2, movie 3, ... movie M, okay? And so for every single one of these, the users will rate movies. Now, will there be a rating for every single movie? Not necessarily, right? Not necessarily, because some movies you've never seen, so you've never rated. So there is that issue. So that's an issue that, sometimes you'll end up with like a null value for a movie you haven't rated. So you have to kind of think about the best thing to do here. So in my example, I'm just going to set those values to 0. Okay. So movies that haven't been rated by a person, we're gonna put in a 0 there. However, as you're trying to make your algorithms better, it might turn out that you need to do a little bit of research, read the literature and figure out, well, actually, should it be zeros or something else? You see that? So that's one of the key things. Give me a sec. Let me grab some coffee. All right, otherwise my throat gets too dry. All right, so now, so we have our data, right? So that will be the key thing. Now, I'll go in a more formal definition of singular value decomposition. I will give a much more formal one, but just right now, basically what singular value decomposition does, in big picture kind of thing, is that you start with the X matrix, right? So you will start with an X matrix like this, right, which is n by m. And singular value decomposition, there's a technique in linear algebra, there's a theorem actually that says that any n by m matrix can be actually split into three matrices. So we're going to end up with three matrices, okay, which are called usually U, this one's called V, and this one has several names. One of them looks like that. I think in the code, it'll just be S, okay? So it'll just be S, so maybe I should just use S instead, okay? But you end up with three matrices. And the key thing about these three matrices is that they have, they create, and they're the same size, by the way, so they're going to be like square these two are square matrices. So they're going to have, they look like this. So the U matrix is going to be n by n, right? So, and the idea is that you have, but let's not worry so much about the sizes, but more about the intuition, okay? The intuition is that this will be users to concepts. Users to concepts. This one for now is, let's just say it's going to be a diagonal. And then this one over here, the V1, is going to be concepts to movies. So what that means is that it's going to group, right? You know, the users based on a concept. It'll find these concepts. You don't know what these concepts are, but the singular value decomposition hopefully finds them. So for instance, let's say that the first concept, the first, principle one here will be the concept for science fiction. Why? Because a lot of movies out there, The Matrix, Star Wars, Star Trek, all of those are science fiction, right? So a lot of those movies will have strong values in this column. Then it might pick up another one like historic, right? Like Out of Africa and something about the Second World War. So those movies would have high values in that column and low values in other columns. There might, another one that it might pick up is like comedy or romance, right? So those are usually genres. So if you think about it, it's a similar idea to like in like clustering the data, right? So like creating groups of data. So if you think, this is what you guys probably do, right? So if you're at home and you have a lot of DVDs, you might say, okay, I'm gonna classify my DVDs, and I'm gonna put these DVDs, and these are all like science fiction, and then these are all my Marvel DVDs, and these are all my action DVDs, and it just makes it easier for you to find movies based on what you want to see, right? So we do that already. Well, it turns out that this algorithm, singular value decomposition, although there's more to it than what I just said, when we look at the theory, I'll talk more about it. But this algorithm does something similar to that. So you have users to concepts, right? So that way you're going to figure out, that user has a high contribution, a high value in some concepts and a low value in other concepts. And therefore, this is the information that you use to infer the recommendations, okay? That's what I want you to understand, that's the information. On the other end here, you have the same thing. You have movies, and now the movies fit into these concepts as well, similar. So all the movies that are related to sci-fi might have a high value here. All the movies that are related to romance might have a high value here, and so on, right? And here over here would have been based on users. So users have a high presence in sci-fi versus action or something. Does this make sense, guys? Does this idea make sense? Any questions?
No questions. This makes sense.
All right, good. So as I said, we have to more formally describe how it works, but basically this is the idea. We come up with these three matrices. And then the third one, the third one is very interesting because it says how important these columns are, right? So it says, for instance, yeah, the first column has a value of 1. So that's a really solid one. I was pretty sure that I found some good grouping there. The second one, I would give it like a 0.70. It means, yeah, you know, maybe they're you know, users can fit into that category and it has some meaning. And there might be for the third one, it just says, you know, 0.1. Really, that column that I came up with is not that great. It doesn't really translate into romance, sci-fi, comedy. I don't know what it is. You know, maybe you can use it, maybe you can't, and that's why I'm saying it's 0.1. And all of these calculations are done through the algorithm. So the algorithm, you know, it just works that way, and it works really well. But anyway, that's the intuition that I wanted to give you, and so now you understand. What do you understand about, you know, the recommender system? You understand it as a black box, at least, before we look at the sort of how the algorithm works, because you give it X, right? Users, movies, and you feed it into like a black box, right? The recommender system, and then it's just gonna give you U, S, and V, right? It's gonna give you these 3 matrices, and then now you use these 3 matrices, which have this intuition down here, to derive meaning, okay, and recommend movies. So this is what you guys will do for your homework. I will give you the algorithm that does this, but then you will get US and V, and then I might give you a few functions here and there to kind of play with it, but you will have to use that information to make recommendations, okay? And so you will have to find some data set of something to recommend, and there are plenty of data sets out there. All right, so now that I've given basically the big picture, we are ready, I think, then to look at the code. All right, so now it's code time. And so we're gonna do the code, and then you guys can, you know, and then hopefully then on Friday, oh, sorry, Friday. On Wednesday, we will go over, on Wednesday, we will go over the theory of this, of how you would use, because it's really straightforward. You know, I want you to understand the code I'm about to give you is super straightforward. There's basically one function, right? It's like a function, you call it singular value decomposition, you give it X, and guess what? It gives you US and V. That's it. The really hard, or not the really hard part, but the hardest parts are really getting the data, you know, getting the data X basically. And then once you have US, V, you know, recommending. That's it really, right? And I already explained to you how this could be done if you were implementing a system, right? So if you were implementing a system, you have your website over here, you have your database, you're in MySQL, you have the data in tables, you know, relational tables in your database. Now you just need to download them every night, run a cron job for that, run your script, you know, with everything. This gives you, now you know this gives you USV based on that X. You need to then run that through some additional code, right, to figure out what to recommend, and then feed that back into the database itself. And then next day, your users come in, they check, they get all these very nice recommendations down here, and then you as the owner of the company are really happy because, you know, where you had that before, now you have, you know, more, right? ... hopefully. And then we can all retire, you know, early, right? So that's basically the idea. Okay, so that's the idea. All right, so if you don't have any questions of any of this, then let's just proceed to the coding part. All right, so to do the coding part, I haven't added yet the link here. I probably need to add that link on here, recommender, but I already have this on my GitHub. Okay, so let me open the course website. Okay, so now we're gonna code a little bit. And as I said, the hard part I already showed is really just getting the data and then analyzing the data. The singular value decomposition part is actually pretty straightforward. All right, so here we are in the course website. So let's scroll down. And you can see here, if we look back, remember the singular value decomposition here is part of feature ranking, but it would also be its own machine learning algorithm. I guess I didn't quite put it in this list, but it's one of them, right? So let's go over here and let's go, you can see in the week, this week, right? We're covering singular value decomposition, recommender systems. So let's go to GitHub. Oh, there it is. All right, so if we go to the GitHub here, you can see I already added a little folder. So I've added a folder here, singular value decomposition, because I really wanted to group, since there's going to be code for two things, right? I wanted to kind of group them within this. So if you click on singular value decomposition, you can see I've already added recommender and compression, right? So compression would be the other topic that I said we were going to talk about, but today we're just going to focus on recommender. So I'm going to click on recommender, and you can see I've already added the code, the Jupyter Notebook, and the Python scripts. You can follow along. This is a simple recommender system using singular value decomposition. Now, the first thing we need to look at is the data, right? So I'm going to click on here. I already downloaded the data. You can see this is the data for movie reviews. If you want to, learn more about it, here's the text file. You can see it's from movielens.org. It's a pretty, well used data set. Okay. And it's got here, you can read through this. It's got all the information, all the details, so you have a better understanding of it. But let's go back. Let's just take a look at the data a little bit more. So the way that this is done is that you have the ratings, right? So first of all, you have the ratings. So if you click on ratings, and there it is. So there's the data. You can see it's basically user ID, followed by movie ID, followed by the rating and a timestamp. So that is to say, user one, look at user one. User one will evaluate several movies, but not all. You can see user one evaluated movie 1, movie 3, movie 101, and so on, and then they give a rating. So user one thought that movie 1 had a rating of 4. Okay, they really like 47. And then user one seems to like all movies, right? So every single movie got a rating of 3 or above. But that's the information that we're going to be using. That's the critical information. This is basically the X matrix, right? Because this contains which user, which movie, and the rating. So this is really the X matrix. The other tables there are really just lookup tables, because obviously if it's user 1, well, we want to know who that is. And if it's movie 70, okay, we want to know what movie that is. Okay, so if I go, for instance, to the data again, if I look at movies, right? So if I click on movies, you can see here movie 47 is 7. Right? A 1995 movie, mystery thriller. Or it is, movie, movie 44, Mortal Kombat, also 1995, It's an action adventure fantasy. So you have that data, obviously, that could be useful to you when you make the recommendation. So because you don't want to say, okay, I recommend to you movie 3. Well, you know, what is movie 3, right? Tags, this one, it's basically additional information about the movies, like people wrote, you know, something about them. So user ID, which is 2, for movie ID, so-and-so said Tom Hardy, or they said boxing story, or Will Ferrell, right? So this we won't use. This information you could use for something else, but for this problem, we are not going to use it. I already showed the movies, and then you can look at links. And links just has something to do with the movie and, you know, IMDb or, you know, information like that. This we are also not going to need. So really, we only need movies and we only need ratings. These only 2. Obviously, the users for privacy, you know, those were real people, so we only have their numbers. We don't have their names. Okay. So that tells us that we only need movies and we only need ratings, and we don't really need anything else for our problem, right? We already know that ratings is ultimately the table that contains our data. But it is but it's not, that table contains about 100,000 records, okay? So there are 100,000 records in that table, but that data is not a 2-dimensional array, right? So it's not like we need it. So that's one of the first problems, right? So one of the first problems, if I go back to the whiteboard, is I have to deal with that. So as you can see, as I said to you, really the hard part is not dealing with the singular value decomposition, because a lot of that is just one line of code. It's really dealing with the data. And so really, when I was working on this, you know, last night, that's really what took me a long time. It was getting the data in the appropriate format. Okay, so let's take a look at that idea. And please stop me at any time if you have any questions. All right, so we need, for singular value decomposition, we need something like this: users and movies. But what we have is, we have a list, right? A list, that file ratings CSV. So we have that file, and it's got the user, the movie, and the rating. Okay, so it's got the user, the movie, and the rating. Okay, that's how the information is being shown. So I have user 1, 1, 1, you know, you saw that, and then movie 2, movie 7, movie 5, movie 18, you know, whatever, and then the rating 4, 3. Well, what we need is that when we have for this user 1, right, and for movie 2, movie 7, movie 5, movie 18, right, and then we plug in these values. So it'd be 4, 3, 1, 1. We need to go from this one to that one. Okay, so you know, so that's really the hard part, honestly, of this. Now there are several ways that you can do this. I thought about how to do this. There's a lot. Another little problem with this. The other problem is that for whatever reason, there are, this one's easy. There are 620 users in the data. And there are about 9,000, I don't remember the number, I think it's 9,724 movies. But unfortunately, the movies weren't named from 1 to 9,724. They have IDs that go from 1,000 to, sorry, from 1 to I think 97,000. So I have, you know, the movies go from 1, 2, 3, but skip numbers. So they might jump to 17, and then they go to like 90,000. I don't remember exactly. So making a matrix like this from 1 to 90,000, so that is to say that we could number from 1 to 90,000, right? But that's going to create a really huge matrix. And this would be only from 1 to 620, but this one, 90,000, when we try to do singular value decomposition on this, it's going to be pretty intensive on memory, because that's one of the downsides of singular value decomposition is the memory impact, right? So you need a powerful computer with a lot of RAM for it. So we don't want to use that where we have a lot of missing movies. So what I ended up doing is I created like a mapping, right? So I did a mapping in a dictionary, if you will, where although they go from 1 to 90,000, I can do a lookup that just goes from 1 to 9724, right, for this problem. That way, I wanted to use this data, but I really didn't want to have such a huge matrix, okay? Because my computer, even though it's got some power, you know, would just get, it wouldn't perform. So this is really 1 to 9,724 or so. All right. So those are the dimensions, and I actually hard coded that in the code. Okay. And I also did the same for the users, although just in case that maybe there was a user missing or something, I did the same. Although it wasn't such a big deal with the users, maybe I could have just left some users in there. As I said, just for the dimensionality of it, I did a mapping here. So what's going to happen is whenever you say something about movie 9,724, you actually have to do the lookup and find out that the real ID is 90,000, and then you can look it up in the text files. Okay. Does that make sense, guys? Questions about that?
Nope.
Questions, all right. That's good. When you do your own homework, you'll probably do something similar to this where, you know, because you just never know what numbering system they're using, but I think a mapping should work really well. Well, like I said, a lot of the code was really just this. This is what took such a long time. And then everything else, as you will see, is pretty straightforward. We're going to be using Numpy, so you're already somewhat familiar with that. And as I said, the part that gets this is just one function, okay? Although in the lecture, I will basically describe the singular value decomposition algorithm just so that you have a better understanding of it. And in particular, because I want you to do the analysis of these matrices, right? So that's going to be your homework, is how do you make sense of what's going on there, although I will provide some helper functions for that as well. All right, so I think we're ready then. If you understood this idea, right, this idea of getting the data, you should be in pretty good shape. Okay, so now so what you need to do now is you need to obviously download the two files, right? So you'll need to go back to my GitHub. So you will need to go into this SVD recommender data, right? And you will need to download really movies.csv and ratings.csv. Those are the only two files that you will need. Put them in your in the folder where you have your Jupyter Notebooks, and then that way you will be able to, you know, to read in the data. So that will be the first thing. So I'm going to go ahead now and get started with the code. So to do that, we're going to need to start up our Jupyter Notebooks. So let's go ahead and do that. All right, so I'm going to go ahead and start Jupyter. All right, so you can see here, I don't know if you can see this. Yeah, you can see here, I already have the data in there, rating CSV and the movie.csv, okay? So that's really what all I'm gonna need. And now I'm going to create a new script, right? I'm gonna rename it. I'm going to rename this. I'm going to call it recommender system. Recommender system, you know, in class, because this is the one that we're doing in class. Did I misspell something? No. All right, so that's renamed now. And so we can proceed then to create our recommender system, right? So we can, you know, we know where the data is, and so we can get started. It's not that much code, as I said, except for the part about dealing with the data. Now, we will do some normalization and some things like that. And, you know, little steps like that, but it's not really that extensive. Okay. Let me load this. All right, so a couple of libraries that we're going to use. You know, obviously, we're going to use Numpy. Import Numpy as NP. Now, a new library that we're going to be using this time is Pandas. So Pandas is very useful, and so we might need it. So let's just add it in here for, you know, whenever you're dealing with a data set that's in a CSV, you know, at that point, probably Pandas will make its way. Pandas is just a really powerful library for manipulating data, all right? So it's not for machine learning per se, but it's for data manipulation, you know, just formatting, dealing with formats, etc. So that's one of the main goals. Okay, so this is the plan. We have then, you know, remember, I'm going to be using the data set is using the movie lens data. Movie lens, using the movie lens data set. There are several versions of it. There's a version that's like 1 million, and there's a version that is smaller than 1 million, you know, so there's a lot of data depending on what. Obviously, I tried to use something that had a good amount of records. It has 100,000 records, right? So this one has 100, you know, the one used here has about 100,000 records, as I described previously, and that results in about 620 users and what is it? 9,724. So it's 9,724 movies that have been rated. So for a total of 100,000 records or total ratings. Okay. This is the website here. It's in the GitHub, but if you want to check it out, it is on the Group Lens website, grouplens.org. So you can check out their research there. It's a pretty they're pretty into recommender systems and collaborate filtering and all that. Anyway, that's basically the data set as we've described it previously in the lecture today. All right, so now we can go ahead. As I said, the first part is just dealing with the data. So let's start with just kind of taking a look at the data. So I'm going to grab the data with Pandas and just get a feel for it. You know, we want to do that. We want to get a feel for it. This code is so short that I'm certain that we will be done with it by by Wednesday. So I'm not so concerned about that. But as I said, I do want you to have the code before the theory, just so that you can start working on your assignment. All right, so you know, we have pandas, so I'm going to use pandas, and I'm just going to say read, you know, CSV, right? So it's a function there, and I'm going to read in just the file. I'm going to read the file from my recommender folder. So you know that I already downloaded the file. So from recommender, and the file that I care about mainly is ratings, although movie CSV I also need for the movie names. Okay, so because, you know, like I said, I want to be able to see, okay, you know, I like The Matrix, I like Star Trek, whatever. It should recommend some sci-fi movies, right? That's the proof, you know, the proof that it worked. All right, so I have the file, you know, read in here now. So now I can proceed to list all users, for instance, right? So I want to do list the users, so I can do users, and then I just grab data from data, and I'm going to grab by the column. So here it's going to be user ID. You have to look at the exact names. So you'd have to look in the file and what they're called. So they're written like this. And then I just want all the unique values. Oops. So all the unique values. So this will give me a list of all the users. And then I'm going to do the same for the movies. So I'm going to say movies data. And now I'm going to grab all the movie IDs. This gives me all 100,000. By doing the unique, I get rid of repeated ones just to see what the unique values are. And, you know, I can calculate the length, etc., which will tell me then how many I have, right? So, which I already know. So I have unique here, right? And then now I can just do a simple print statement, and I can print out, let's say, users. Let's go ahead and do that. I'm going to run it. So if I run this, oh, there's an error. Uh-oh. Any ideas? Oh, it's a typo. Okay, try it again. And you can see there, these are the users, right? So you can see 1, 2, 3. I don't know that there are any missing users, but there could be. But this would be a way to spot them, right? So they go from 1 to 610. We could also do the length of this, so I can do length. Okay. Run the length. That didn't work. This Jupyter sometimes doesn't keep the parentheses. See, 610. Now, if I do the movies, you know, there's no reason to print out the movies, so we can just look at their the size. So I do the same movies, 9,724. Now, obviously, you can get the values like this. I will hard code them just to kind of, you know, to be more clear about what we're doing. But that's the idea. Questions so far? Doesn't sound like you have any questions. So now that we've looked at that, we could also look at the data itself. In here, we've already looked at the file, obviously, but there are ways in Pandas that you can do that. You can do data. Oops, you can do data, and then head, and it just gives you a little bit of information of what the ratings matrix looks like, right? Which is the one that we read through. So I can hit run, and you can see here's the data. So I've got user IDs there, right? movie ID, and the rating itself. I could also do a length of one of these to know how many samples we have. We'll do that later, but basically I already know there's about 100,000 entries in there, as I had described before. So now that we have a feel for the data, let's go ahead and read in the two matrices, right? So I'm gonna need the ratings themselves and the movies. I kind of want to have them in a separate, that was just really to view, but now I really want to have them for the processing that we're going to do. So this is ratings, so data underscore ratings. And I'm going to use pandas again, and I'm just going to say read underscore CSV. And I'm going to read in the file. So it's going to be in recommender. Okay. And it's the ratings.csv. I also want, I'm going to copy this, the movies one. I'm going to say data movies here. And this will be movies like that. All right, so now I have my two files ready to go. And really the problem, as I described, is that they don't look like what I need, right? So if we go back to the right to here, if you remember, we're reading the file that looks like this one, but we need it to be in this format, where the users are the rows and the columns are the movies, the movie IDs. So we need to transform it from that. And that's really the majority of the complexity of the code. Everything else is pretty straightforward. All right, so here we can take a look then at the next step. And you know what? I usually like to do this as kind of a thing I do just to know when it's done processing, kind of for debugging. I do it, just add this print here. Done. That way I know that it's running from beginning to end. So now that I have my data, if I wanted, for whatever reason, although I'm not going to do that right now, but if I wanted to split the data into train and test, there's basically an easy way to do that. Using pandas, I can just create a train set, right? Which is going to be, I just use, data. I'm going to use the original one because this is just a comment in case you guys need it later. I'm adding this. So I'm going to say sample, and this will sample from the original data. You have to say what fraction is the test set, so in this, or the train set. So in this case, you're saying fraction is 80% for training. So that's going to be 0.8, comma. And then obviously you always, because you're randomizing it, the selection, you can give it a random state. So select a value like 200. Now, if you want a test set also, that's going to be the 20% that it's not in the train set. So to do that, you can just say data.drop. So basically this way, it'll drop all the samples in train. So then just say train.index. And it's as easy as that, right? So this is another way of do train test split, but whenever you have a pandas frame, right? So if you have a pandas frame, you can do that as well. So as you start to do your analysis for your homework, you may or may not need these. So I'm just giving you this code just in case. All right, so now let's proceed with our main challenge, right? Need to convert data ratings into the X matrix, right? So that's the first thing that we're going to need. So we need then here creating the rating ratings for X matrix, okay? Which is going to be rows as movies and columns as users. Okay, that's the way that we're going to build it. So then the first thing we could try, there's a lot of ways that you could do this. I tried to do this as intuitive as possible. So here then we can do ratings underscore matrix. So this is going to be my X matrix. Okay, I'm not calling it X. I'm just going to call it ratings matrix because, you know, it's just a name. I'm going to create a numpy of zeros. And as I said, because I don't want it to be, I could have just used all the existing IDs, but the problem is the IDs of movies go all the way to 90,000, and it's a sparse matrix. And there's ways of dealing with sparse matrices. But I just decided, okay, I'm going to count how many I have unique. We already know we got 620 by 9,724. So I'm just going to build that matrix and then do a lookup of the corresponding index here to the real index in the data. All right, so I create notice also that whenever there's a missing value, it's going to be 0. Okay, so if a user never rated a movie, it's going to get a 0 value. Okay, which kind of makes sense in the sense that that user would not maybe, you know, that movie would not influence so much as one that has a high value, right? So now let's create the matrix. So it's going to be shape will be equal to 9,724 by 610. Okay, so that's the shape of the matrix that we want. That's something that, you know, your computer should be able to handle. And then the data type, we can change this later. For now, let's just give it a data type of uint8. We could change this to float also, and that might be the way to go. So we can explore all of that. And we've already seen how to do this when we were doing the NumPy example. Now we want to just look at the shape of the matrix, make sure that we created it correctly. So I'm going to do ratings matrix. So ratings underscore matrix dot shape. Okay, I'm going to go ahead and save that and run it. And you can see it is indeed a 9,724 matrix by 610. So that completes that part. Now the next thing we need to do is, because we have this problem of having movies that have an ID of 90,000, 91,000, but then we have, when we don't have 90,000 actual movies, we only have 9,724. I want to do this kind of in lookup table, right? I want to have index values that I can look up for the actual IDs, but I want my matrix to be small enough. So that's really, and as I said, there are several solutions to this, I guess, but this is just what I did. All right, so now I'm going to create the ratings array. So the ratings, obviously, this is going to have all the ratings, and this is going to be about 100,000. So I can do from data ratings, the ratings matrix. I'm going to grab the rating column, okay, and I'm going to get all its values. I have all its values. I'm going to repeat the same exercise and get the values of also the other ones, right, because I'm going to need them. So from the, I'm going to create also now a movie IDs array. Movie IDs array. And I'm going to create a user IDs array. All right, so I'm creating these three. They're going to be from the data ratings here, but we're going to grab movie. So the column movie ID, and I'm going to grab the column user ID. Okay, so now I have these values, and now we can proceed to print them out, etc., to take a look at what they are. So here I can do print, and I can just grab this one, the rating IDs, right? And now this will be very big. So if I run it, you can see the matrix here. These are the ratings. Obviously, it's not showing all the data because it's got the ... But that's that one. Or I can show the movie IDs. Okay, run that one. You can see the movies. Actually, I was wrong, right? So you have movie IDs that go as high as 170,875. So that's why I decided, and notice it skips. So there's a movie that's 168,252 and then 107. So, there's a lot of missing IDs there. And so for whatever reason, I didn't want to use, these numbers because I didn't want to have 170,000 matrix by 620. User IDs only go to 620. So you can do that. You can see that here. Run it. And there it is. Or sorry, 610 from 1 to 610. Yet my index will go from 0 to, I guess, 609. But anyway, that's basically the data. If we want to print out just one of these to get the length, you'll see that it is about 100,000 records in total. And there it is. It's exactly 100,836. That's the number of individual ratings that we have, where we have a user rating a movie and giving it a value. We have 100,836 of these. Okay, and so if we multiply 610 times 9,724, that gives us about 5 million cells, right? But it's a lot of those are just zeros, and we don't really have a value in there. But however, that's a pretty big matrix in itself too. So that's why the memory issue is important, okay, for you to consider. When you do this homework, if you guys have issues with memory, let me know, because we do have Scholar now, and so you guys could potentially just use the cloud Scholar, which might have more powerful computers if your laptops can't process this. So I very strongly recommend that you use something that doesn't have more than like 100,000 records, unless you have a very powerful computer, because this will tax your memory. All right, so now that we've done this, we've looked at the data, and now begins the process. The next step in the next 10 minutes, we'll start to talk about this conversion from these 100,000. So here, you saw already that we have from 1 to 100,000, what was it, 800 something? And we need to convert it into our X matrix, which is going to be that one, right? So we need to convert it into that. And so that's what the code is for. Also, to deal with this idea of the IDs, I'm going to create these dictionaries, okay? But that shouldn't be too bad. And you'll see, now dictionaries in Python are really fast. They're hash tables, basically, so they're a good data structure to use for lookups. And so I will use it, and I'll show you a little trick so that really quickly you can retrieve the data that you need for your recommender system. So let's go ahead here, and now we're going to create dictionaries. Create dictionaries. Okay. I call these dictionaries of ref to real. So what I mean by that is that I have an ID like 5, and that ID maps to movie 47. And then I have an ID of 9,700, and that maps to movie 160,584. It's just a little mapping to reduce the dimensionality. You guys could try other approaches. This is just one that I'm trying. As you can see, that a lot of the code is just really this, right? I haven't really done anything else. So I'm going to create the dictionary here. I'm going to call it movies unique for the ID, then dictionary. And then notice I'm going to do the dictionary and then the reverse of it. So what I'm going to do is I'm going to say ref to real. So that is whenever I have an ID, I can look up the real ID. Okay. And so I have that dictionary here. And then I'm going to do the reverse. Movies unique dictionary, and this time it's going to be real to ref. So real to ref is sort of the opposite of it. So whenever I have, the dictionaries are basically the same dictionary, just in reverse. So now, but for quick lookup now, whenever I have a real ID and I want to get the reference ID, I can just look it up here. So I'm going to populate both dictionaries at the same time. This is a very common approach, and whenever when you do lookups, to have the dictionary and the reverse dictionary, just to speed up your processing. Then I'm going to do movies uniques. So I want the unique IDs right from the data. So movies uniques. And to do that, I'm just going to use the numpy function .unique, and then I'm going to take as input all the movie, the movie IDs array that I just created previously. So I'm going to do movie IDs underscore array, right? So I take that, and it's going to give me only the unique values. So now there will only be 9,720, and we can corroborate that in a second. So actually, we can do it now. So if I do print length of movies uniques, that should be 9,000 something. So I'm going to run that, save the file, and you can see it's 9,724. So I've got the unique values now. I can get rid of this. I don't need it. All right, so now what I need to do is I want to create the dictionary where I have an ID associated, a reference ID associated with the real ID. So I'm just, lots of ways of doing this. I'm just going to do a simple for loop. So for IDX res in enumerate, and I enumerate through the movies uniques, right? Because I just want, for the unique values, I want to create a mapping. So I'm going to do movies uniques, right? And I have that. And now I'm going to populate my dictionary. So I can just grab both of these, grab both of those, and I'm going to populate them so that I have them available to me. So now, get rid of this, get rid of that. So let's populate the first one. So movie uniques, dictionary, reference to real, right? So in reference to real, we want the reference, which would be IDX, to give us the real, right? And the real would be res. Okay, so that is to say, I have ID 9,723, and that is equivalent to real ID 170,524. Then over here, I do the same for this one. But this is the opposite. This is movie uniques real to ref. So in real to ref, this is res, and it's going to give me the ID, IDX. And that's just, so I can just do a really quick lookup of my data. That's it. That's that's it for that one. Then you want to do the same for the users. So we can copy this code basically. All right, we can copy this code. And again, just do, this is going to be users, uniques. These should have been uniques, I think. Let me just, uniques. Just so I'm consistent. Uniques. Then here, this one would be user uniques, right? Dictionary, ref to real. Then users, uniques, dictionary, real to ref. So I've created those two dictionaries now. Then the same thing for IDX, res, in enumerate, but now it's going to be, of course, users, uniques, or oh, I don't have that yet, so I need to, I skipped this part. So I got to get here the users uniques. So I'm going to say users uniques. I'm going to call NP unique from user IDs. So user IDs array. All right, now I have it. So now I'm going to iterate for IDX res and enumerate users uniques. Users uniques. Okay, and then finally I populate the dictionaries, users uniques and users uniques. And it's the same logic as before. So if it's ref to real, I'm going to look for the IDX and get res. If it's real to ref, I'm going to look for res and get IDX. Again, just to have a really quick lookup. So let's print out one of these actually so that we can see it. I think movies is the more meaningful one. So let's go ahead and print that one. So I can do here print, and we'll stop with that for today and then continue this code. We're almost actually there. You'll see we'll finish it up on Wednesday. So now I can save it and run it. If hopefully there are no errors. All right, you can see the dictionary there. Scroll all the way to the bottom. And you can see, for instance, movie 193,609, that's the biggest ID, real ID, is mapped to the reference 9,723. And so now we have our lookup tables ready to go, okay? So I'm gonna go ahead and comment this out since I don't need it. And this is actually a good stopping point for today. You can see there the data is set. So currently, I have the IDs. I still haven't created the X matrix, but we're pretty close to creating it. And then you'll see everything else is pretty straightforward. All right, so that's it for today. So let me go ahead. I'm going to save this. Stop sharing. All right, so I'm going to stop the recording now, and this concludes our discussion for today. And then we will finish this up on Wednesday.